In this video, we're going to look at a common algebraic technique called completing the square. So completing the square is quite straightforward with some practice, but it does tend to cause some confusion at first. And that's partly because there are two different forms for completing the square. Students will tend to get those muddled. Also, in the more basic form, which is really just a one-step algebraic process, students will tend to add in too many lines of work in, which causes a bit of confusion. And in the more complex form, which is a more difficult technique, students will tend to not put in enough work in, which also leads to confusion. So we're going to work examples of both types in a moment. It's important to be competent with both types and to recognize the difference between them. But before we get there, let's just start by very briefly taking a look at the theory. And the theory here really is that we're taking quadratic expressions. You'll notice that these are all quadratic expressions. They've all got an x squared term in them as the highest power, in other words. And we're rewriting that quadratic expression in a type of factorized form called the completed square form. But it's a very particular type of factorizing. It's not two bracket factorizing. It's not a difference of squares. It's not a common factor. Those are the common types of factorizing, the three types. This is a different type called the completed square form. So we're taking a bracket with a squared on it. So a bracket with power 2. And inside the bracket, we've got our variable x plus or minus some value p plus or minus some value q. So we're going to be turning our quadratic expression into this completed square form, but the two things are still the same. They're equal to each other, so it's really important to know they're just the same thing rewritten in a different form. And that's true for all factorizing. You take some expression, you factorize it into a bracket or two brackets, and it's still the same expression, just written in a different way. So we want these two things to be equal, and that's the technique we're going to learn and practice in this class. So this general form, of course, looks very confusing because it's got half the letters of the alphabet in it. So let's move straight away from that and look at an actual example. So this would be a typical example of a completed square form. So we've taken this trinomial, this quadratic expression, x squared plus 4x plus 10, and somehow we've been able to rewrite it in this form here. And that's the technique that you need to learn. Now notice that if you were to take the thing that we think is the answer here, x plus 2 all squared, well, x plus 2 all squared, remember, just means x plus 2 times x plus 2. So when you write a bracket squared, that really means the bracket times itself. And then we've got this plus 6 hanging out on the end. If you multiply out that bracket, you're going to get an x squared, you're going to get a 2x term, another 2x term, and then a 4 from the 2 times 2, and then you've still got the 6 on the end. If you simplify these terms, you've got 1x squared, you've got two 2x's, which combine to make a 4x, and then the 4 plus the 6 gives you a 10. So notice that just by multiplying out this bracket here, we've kind of validated that we did, in fact, get the thing that we started with. So in other words, this thing here, the completed square form, and the original trinomial form are the same thing, just written in a different way. Now, you don't have to do this check every time. I just wanted to run through that check just to prove to you that this here and this here are the same thing, just written in a different way. So the question, the challenge for us is, how do we get from this form to this form here? Well, the technique is very straightforward for this more basic case. For the more complex case, it's slightly more challenging, but in both cases, it's very procedural. If you follow the process every time and practice it a little, you'll be absolutely fine with this technique. This should just be a one-step process. Let me show you how it works. So you can go straight to writing down your bracket, and if it's just an x squared term, in other words, a 1x squared, so not anything higher than a 1. These guys have got something higher than a 1 coefficient on the x squared term, and this is a different case. But all of these guys here, in the more basic case, have just got a 1x squared, and that's what defines this more basic scenario. And if it is that scenario, then you're just going to start by writing your bracket, opening your bracket, and just putting an x in the bracket. Okay, so that's always going to be the case. And then to fill in the next part of the bracket, you just take half of the number in front of the x. So half of the coefficient of the x, which is 8 in this case, half of 8 is 4, retaining the sign, okay? So if it's a plus 8, it'll be a plus 4, and then you just close your bracket and put a squared on the bracket. So that's a no-brainer. That's going to happen every time for this more basic case. Half of the coefficient of the x term, put that in the bracket, put a squared on the bracket. So you're literally going to do that every time. This is a part that tends to cause the confusion. Some people like to do this next part over 2 or 3 lines of working, but it doesn't need to be over multiple lines of working. All we're trying to do is to figure out the outside value, like the q value. It can be a plus or a minus, depending on the signs in the original trinomial. But all you're doing, once you've landed this number in the bracket, take that number, 4 in this case, and square it. You don't need to write that down, you can just square it in your head, or if you want to write it as side working, that's fine. 4 squared is 16, so that's telling you that this bracket squared would give you a 16, but remember, we want these two things to be equal, so we don't want 16, we want 20. So how do you get from 16 to 20? Well, you just add on 4. And that's it. So I've explained that process quite fully, but really that process only takes about 20 seconds. So open the bracket, put half of this number in the bracket, square it in your head. 4 squared is 16. You don't want 16, you want 20. So to adjust that number from 16 to 20, you would need to add on 4. Let's take that technique into the next example, so we can speed this one up. So open your bracket, put in the x, put in half of the coefficient of the x term, so half of 6 is 3, again retaining the sign, so it has to be a plus 3. Put a squared on the bracket. 3 squared is 9, we don't want 9, we want negative 2. How do you get from 9, positive 9 to negative 2? You take away 11. Done. Simple, right? Next one, slightly different problem because we've got a negative coefficient number in front of the x term. Doesn't make any difference really, you just do the same thing, open the bracket, put in your x. This time it's just going to be a minus 5, it's still half of the number. Put the squared on the bracket. Be a little careful with this because remember that it doesn't matter if a number is negative or positive, when you square it, you always get a positive. So this is minus 5 all squared. Minus 5 all squared is 25. We don't want 25, we want 19. So how do you get from 25 to 19? Well, you need to subtract 6. So notice that n number can be a subtraction or it can be an addition. It just depends what the numbers in the original quadratic expression look like. So that more basic form should be very straightforward. You don't need more than one line of working. You can basically just do it by that technique that I've shown you there. Okay, so it does need a little practice though. Let's move on to the more complex technique. So the way that these are set up, and the thing that makes them different is because they've got a coefficient, which is a coefficient of the x squared, which is non-1. It's going to be something bigger than 1, so 2, 3, can be any number. It tends to be 2 and 3 in most problems. But the thing you'll see in most of these problems is that the first two coefficients, in other words, the number in front of the x squared and the x, will share a common factor, but the third term, the number term in the trinomial, will not share that common factor. And usually it's two even numbers and an odd number, although not always, but it's definitely going to be two numbers that share that common factor and then some number that does not share the common factor. If they all shared the common factor, then you could do common factor type factorizing, which would then take the problem in a different direction. So these problems will always be set up usually this way. So slightly more lengthy process. The process starts by pulling out that common factor, but just the number part of the common factor, because 2 is a common factor here, x is also a common factor, so the highest common factor there would be 2x, but we just for this technique pull out the numerical common factor, and then we're going to use a square bracket. So we need x squared plus 6x like that, and we're only factorizing on the first two terms, and then we're leaving the number term just hanging around on the end like this. So at this point we've not completed the square, we've just pulled out a common factor. The next part, the next line of working is where we complete the square, and we do that on the inside of the bracket. So we're now kind of using this technique over here. So we're opening our bracket, we're putting in an x, we're halving the number in front of the x, so half of 6 is 3, and we're putting a squared on our bracket, just like that, just like we did over here in these problems. Notice that inside the bracket, you can imagine there being like a plus 0. There's no number term inside the bracket. So to get this here, which would give you a 9, 3 squared, back to 0, which we're imagining to be in here, we need to subtract off 9. Okay? So just like we did over here, but basically the n number is a 0 just for the inside of the bracket, and then we're just leaving that plus 11 on the end. The plus 11, the number term, isn't playing any part in the process so far. Okay, so we pulled out a common factor here, we did completing the square here, so in other words, x squared plus 6x, the part inside the square bracket, and x plus 3 all squared minus 9, these are the same thing, just one of them written in completed square form, this one, and this guy not written in completed square form. So only really in one line of the working in this more complex technique do you actually do completing the square, although we call the overall technique completing the square. So what we're going to do now is just multiply the 2 into the square bracket. So 2 multiplies to this round bracket. Because that round bracket has got a squared on it, we don't multiply it into the bracket, we just multiply it to the bracket. And we're going to achieve that just by parking it in front of the bracket. So it's just going to be 2 bracket x plus 3 all squared. The 2 also multiplies to the -9 to give us -18. And then we've still got our plus 11 hanging out on the end there. And then finally, we just combine the two end numbers. That's all we can really do at this stage. -18 plus 11 gives us -7. So you can see it's a more complex, more involved technique. You can understand, I'm sure, why students get these muddled, but we're basically using this more basic technique within this more complex technique. And you could check this by multiplying out the bracket, multiplying it all by 2, combining all the terms, and you should find that you get that original trinomial expression. Okay, let's just scoot on and try the next one. So similar scenario, we've got a common factor between the first 2 terms, but not shared by the third term. The common factor is 3. Again, we're not using x as a common factor, it's just a numerical common factor. So 3 square bracket x squared plus 4x. And remember that this process is very procedural. You just need to learn the technique, you need to learn and practice the process. Okay, now we're going to do the completing the square inside the square bracket. So it's going to be x plus 2, so taking half of the 4, putting a squared on it, and then we're subtracting 2 squared, which is 4, because there's no number term in here. So the number term in there we're imagining to be a 0. So to get from 2 squared, which is 4, back to 0, we need to subtract off the 4. And then we're just leaving our -5 on the end. And then just multiplying out the square bracket, we're going to get 3 times the round bracket, 3 times the -4 to give us -12. -5 still hanging out on the end, and then the final line is always just to combine those end number terms, in this case giving us -17. So again, if you're new to this, it's worth just taking your final answer for the first few problems that you do, multiplying it back out just to check that you do indeed get the thing that you started with. So the main thing to focus on here is that there are 2 separate techniques. This technique here, the more basic form, is defined by having just an x squared term. This more complex form is defined by having some number greater than 1 as a coefficient of the x squared term, and you can see it requires quite a bit more working. Like I said earlier, students will tend to overcomplicate this and they will tend to undercomplicate this. You really need all of these lines of working. Some students will try and skip out 1 or 2 of the lines, which is possible, but just tends to lead to numerical error. So I would recommend doing this one step by step. Completing the square is a really common technique if you're taking an algebra class or any course which has got an algebra component. And it is just an algebraic technique, but it's got a bunch of uses which you'll see in the future. So one of the common uses, for example, if you notice this expression here, it wouldn't matter what your x value was. This can never be less than 0, because even if x was a huge negative number, when you square the bracket, even a huge negative number will turn positive. If you're then taking a positive, which this bracket will always be, so this bracket's always going to be greater than or equal to 0, and then adding 4 to that, plus 4, then the whole thing is always going to be greater than or equal to 0. So that is one of the main applications, if you like, of this technique. But if you just start in completing the square, you're just going to learn it as an algebraic process, and then maybe later on in a calculus class or in a more advanced algebra class, you might start thinking about why it's more useful to write it this way than it is in the original trinomial format. So definitely one worth spending a bit of time practicing. Not a difficult technique to get to grips with, but you do need a little bit of practice just to get to that point. So I hope that helps, and any questions or comments about this video, please just leave them in the box below.